Alright, welcome to the fourth video presentation. In this presentation we'll be talking about fronts. Basically they're an important factor of weather, very important to learn about, just like all weather is. What makes them useful is that if we were to identify fronts on a chart before we go flying, we could determine significantly what type of weather we can expect. So in this presentation we'll be going over the different types of fronts. So cold front, a warm front, an occluded front, a stationary front, as well as cyclones, which are associated with fronts. So first we'll be talking about cold fronts. Now when you look on a chart, you'll see that a cold front looks like this. Basically it's a line with these jagged edges. Some people like to refer to them as icicles because it has to do with cold weather. They also, they call them alligator teeth, which is another helpful way to remember the difference between the cold front symbol and the warm front symbol. So with a cold front, definitely we can expect cold weather as it implies. Once a cold front passes, we can expect good visibility, some moderately clear skies, some showery precipitation, definitely some unstable weather. And basically a cold front, since it's colder, is more dense than a warm front. So should a cold front overtake a warm front, it'll cause a lot of vertical movement for that warm front, making more cumulonimbus clouds. Alright, so as I've drawn out here, this is a cold front basically moving into or overtaking a warm front. Now the cold front is heavier, it's more dense than a warm front, so what it's going to do is it's going to push the warm front up at a very steep rate, and this causes basically a rapid lifting movement, which can lead to some cumulonimbus clouds, definitely some turbulence, some shower precipitations, some gusty winds. And so that's the weather you can most likely expect during a cold front. And then once the cold front passes, you can expect some pretty decent visibility and clear skies. Alright, so next we have warm fronts, which on a chart would look like basically a line with these half-sun symbols. That's an easy way to remember. The sun is warm, just warm fronts, so a half-sun, or just, if you just want to have it straightforward, a half circle on a straight line. It can be on a curved line. Okay, some weather that's associated with a warm front is stable air, some steady precipitation, poor visibility, as well as some haze and fog. Basically all the characteristics of a stable air mass. Now, when a warm front overtakes a cold front, rather than before where the cold front overtook the warm, it caused a rapid lifting movement. Well, the warm front is less dense, it's less heavy than a cold front. So rather, instead of forcing the cold front up, basically the warm front is going to gradually move up the slope as it's overtaking the cold front, until finally the warm air is cooled with some moisture in the air, causing some stratus clouds to develop. Alright, next we have occluded fronts, and the symbol for this is basically a mix of the two. You have the half suns with an icicle in between each. And there's two types. The first one is a cold front occlusion. Basically, that's where a fast-moving cold front is colder than the air instead of the air in front of the warm front that it's overtaking. So what happens is once the cold front reaches that cold air in front of the warm front, that cold front just replaces it. It sort of mixes in, and it forces the warm front up because that cold air is just overtaking the bottom. So just as I've drawn out here, you can see close, we have our cold front that's moved in, and basically once it reaches the cold air, it just overlaps it, and it forces that warm front just to overlap on top of both. And this is a cold front occlusion. One thing to remember with cold front occlusions is that it'll have both the mix of cold front and warm front weather. The next front we have is the next occluded front is a warm front occlusion. Basically, it's a cold front occlusion in reverse. The air ahead of the warm front is actually colder than the air inside the cold front. So I've drawn out here. Right here we have the cold air. It's more dense, stronger than the other two. So when the cold front overtakes it, it's also being moved up, and it takes the warm front with it, causing a stationary front, an occluded front right here. Some weather that can be associated with a warm front occlusion is some nimbostratus clouds, some embedded cumulonimbus, as well as some thunderstorms. Okay, next we have stationary fronts. Basically what those are, or what they look like on the chart, is you see a half sun, and then on the other side of the line you see an icicle. Basically it's just one front next to the other. Neither are overtaking the other, they're just stationary right next to each other. They can go and last for days, and usually the weather is a mixture of both warm front and cold front weather. Alright, next on our list we have cyclones. Basically what it is, basically cyclones are responsible for hurricanes, tornadoes, typhoons. They always start with a stationary front, and there's usually a low pressure system in the center. So as I have drawn right here, it starts with a stationary front, but what happens is that there's a small disturbance causes a bend in the front, and it starts forcing the cold front to move towards the warm front, overlapping it. And this creates this cyclone motion here in the center. Now next what happens is that cold air, as you can tell, cold air is on the east side, and warm air will form on the warm air is on the east side, and cold air is on the west side, as the drawing displays right here. And basically the whole time is that these two are moving in close to each other until they become a occluded front. So right before the cold front overtakes the warm front, that's when the cyclone is at its strongest strength, or where it's at its strongest. And finally, when the two fronts become occluded, that's when the cyclone dissipates. Alright, so just to finish up here what we've learned, talked about cold fronts, warm fronts, occluded fronts, stationary fronts, and cyclones. Well, that wraps up my fourth video. Thanks for watching, and I'll see you guys in the next one.